All right. Well, welcome and thanks for joining. You have probably heard through various different LabKey channels that we've been working over the past year converting our build tool from Ant to Gradle. And my hope is that this presentation will help you to make that transition in your own development environment, because the complete conversion is imminent in the 17.2 release time. Which means that Ant will no longer be used as the Gradle build, the LabKey build tool. Just a brief outline of what I'm going to talk about today. First, for any who don't know, I'll give a very brief introduction to what is a Gradle, and then some brief words about why we transitioned from Ant to Gradle. Then a high-level view of what will change in the day-to-day operations of building LabKey, and then the bulk of the time I will spend on how do you do the transition and talking about various developer scenarios that you may have encountered, and then again summarize what the timeline for this conversion is. So first of all, what is Gradle? It is an open source build automation system that was initially developed for JVM projects, is relatively new, and being adapted for other types of projects as well. But it provides a Groovy-based domain-specific language, which gives it a lot of flexibility in configuring and developing build logic. And key to us is that it has a lot of support for dependency management through various types of repositories. It is also very flexible in the repository structure that it can use, and it provides integration with the tools that we generally use, so Intellij, TeamCity, and other tools. So why did we choose to transition? Ant has been serving us well over the past 10+ years, but as you may have heard, the Ant is knowing and wise, but he doesn't know enough to take a vacation, or more importantly for us, it doesn't know enough to handle your dependencies, which is sort of a long-winded way of saying that we have outgrown Ant as the LabKey structure has become more complex. We have more dependencies and more ways to build. The mechanism that we've been using to handle dependencies, which is doing it all by ourselves, has just become more and more cumbersome. So the main reason for transitioning was to get better dependency management, or some dependency management, and using a modern tool for that is a real boost for us. We get project dependencies, we can manage external dependencies, you can get top level as well as transitive dependencies, and a lot of flexibility there, and it handles publishing and retrieving of artifacts from different repositories. Now, because it has to do all of this dependency management, it has more work to do than your typical Ant build. But because Gradle was built from the ground up, assuming that you're going to have multiple projects in your build, it also has the ability to use shorter targeted build steps, so you don't always have to build the entire system, and it also has built-in more flexibility and just better mechanisms for doing up-to-date checks, so it will know when you don't have to build something, and it can just defer that or not do that work. So that's sort of the main reasons for the transition. And so now, just to give you a view of our build ecosystem, we have three main players. We have Gradle, which is the build tool. It configures all the build projects and executes all the build logic. And then we have TeamCity, which is the artifact builder. So as developers check in code, TeamCity will recognize, oh, we've got new code, and then it will run the Gradle builds to build the artifacts, publish those, and then run our integration tests. And the publishing happens to, well, publishing and the retrieval of external dependencies is done through our artifact repository, which is Artifactory. So this is a very high-level view of what changes when we switch from Ant to Gradle. So previously, you would type ant build, and now that will be Gradle deploy app, Gradle W deploy app. And I'll talk a little bit more about why Gradle W in a moment. Build XML in Ant is where all of the build logic is codified, and that is now in a build.gradle file, as well as a number of plugins, some that we have written and some that we rely on from third parties. We had in Ant the .modules file, so standard .modules, for example, that lists these are the modules that I want to include in my build. Gradle has that notion also, and that is their settings file. Settings.gradle is where you specify which modules to include in the build. And produced unversioned artifacts. In Gradle, they will all be versioned, which is a nice thing for discovering, what am I actually running on this server. It is also allows for us to not have the external jars checked in to version control. So in Ant, we have various lib directories that have jar files. Some of them are versioned and some of them are not. In Gradle, everything is versioned, and the external dependencies are downloaded from the artifact repository, Artifactory. And then finally, the Intellij project for Ant was based in the server directory. For Gradle, we moved it up to the root directory, and that was partly for capturing all of the various types of modules that we have. But also it just makes more sense at that top level, so not all of your Intellij projects are called server. So that's just a high-level view of what will change. So how do you do the transition? Again, this is a very high-level review, but on the command line, you'll put Gradle W into your path, and you're going to set some properties. And then you'll obviously use the Gradle commands and tasks or targets to do the build. The Intellij project, as I said, you use the project at the root level instead of in the server level. And you'll use a Gradle window within Intellij to dynamically create the .iml files, which is what Intellij uses to declare the various dependencies that it needs for figuring out class path. And then build script conversion, which I say is possibly optional. So if you have a build.xml, you probably want to convert that to a build.gradle. It may not be necessary in that we have built in the mechanism for recognizing that you have an Ant build file, and we can use that for doing the build within your module, but it may not, it has limited range there. And usually the conversions, and I've done many of these over the past year, are fairly straightforward. And there are several examples within our code that you could use, that you follow to convert. But it's possible that that will not be necessary, and we can just address that on a case-by-case basis, I think. So now we're going to get down into a little more of the details. These are the basic set of files that you'll be working with or that are doing work for you in the Gradle build world. So Gradle W is the Gradle wrapper, which does all of the work. And this is a sort of a nice feature of Gradle in that Gradle is the thing that the Gradle wrapper runs, but they provide this wrapper script so that it's easy to update versions of Gradle. So when you're doing development, you don't actually have to, and you shouldn't, install Gradle on your machine, because by running the Gradle wrapper, it will go get the Gradle executable and download it and put it in its cache, and it'll get the version that we have specified within our properties. And that is important because Gradle is under very active development, and sometimes things change. So you want to make sure that you're using the version of Gradle that our current build scripts work with. Next is the settings.gradle file. As I mentioned, this is the thing that indicates which modules to include in the build. And we'll see an example, a couple of examples of that in a moment. Then there's the build.gradle file, and this is where you do a lot of the configuration. You can also have build logic within the build.gradle file, although it is usually best practice to keep the build logic out of the build.gradle and put that into a plugin. And so that's what Gradle plugin is. We have developed actually a number of plugins that are included in this jar, and various tasks and utilities for use in the LabKey server build. And then finally, there's the Gradle properties file. So that file, and this is a file that can live on in various different places to give different scope to the properties, but it specifies things like versions of libraries that you want, or if you want a development build versus a production build, or things like that. And one other thing to say about this before we actually go look at some of these files is that the .gradle files, as I mentioned, Gradle has its own domain-specific language, and so those files can all have programming within them. So you have a groovy toolkit at your disposal to do all kinds of manipulations, and we have used that sometimes more extensively than others to help us with our fairly complex build structure. So now I'm going to switch to just show you what this looks like in an enlistment. So here you see I have a LabKey trunk enlistment, and there are, within this, I'm at the root level. So I've got my build.gradle, I've got the Gradle wrapper and the version for Windows, I've got this Gradle properties file, I've got the settings.gradle, and if I type which Gradle W, you can see that I've put the version of Gradle in this directory in my path. So now I'm going to just do a couple of commands that are very useful, just to get us started with seeing what Gradle looks like. So the first one is the tasks command, and that command spits out a lot of information about what tasks are available in the current context. And there are lots of things here. We won't go through all of these right now, but the ones I want to concentrate on right now are these help tasks, because they are indeed very helpful. So task is the one that I just ran, and it shows you what you can do at this point. And one thing to say about that is I'm at the root level here, and there aren't a lot of tasks that are only for the root level. Many of these are tasks that are available in sub-projects. So, for example, the JSP tasks. The root doesn't have any JSPs, but for some of the server modules, I can do JSP jar. And one of the features of Gradle is that it will, at a parent level, it will show you what you can do for its children. So that's why you see a lot of tasks here that may not seem like they apply at a directory that doesn't have any source code. Okay, so we saw tasks. Another very helpful one is projects. So if I do Gradle level projects, it will show you which projects do I have configured. And I've got a very small subset here just to make things go faster for this demo. But as you can imagine, this can grow fairly lengthy if you have need for a lot of modules in your LabKey server build. So why? Let's go look at the settings.gradle file that specifies these particular modules. So here's the settings.gradle, and I hope this is. And there's a lot of boilerplate and some not so boilerplate in this file, because I said this is it's a Gradle file, which means that we can do Gradle programming within this file. And we have taken extreme advantage of that because we have so much complexity in and need variability in how we specify the set of modules that you want in your build. So I invite you to read through this file. It has various examples of different ways you can get different subsets of the modules. But for right now, I'll concentrate on a couple of lines here. So this line, include base modules. This is one of the build utilities that comes with the Gradle plugin jar. And as the comment above says, this includes the set of modules for a minimally functional LabKey server. It's a small set of modules, and it will give you a running server. It's probably not going to be where you want to stop, but it does get you started. And then I've commented out most of these lines here, but then I also included just a single other module. I included the study module. So that's why when I list out the projects for this instance, I have a small set, and then I also have the study module. Now you could, that's a fairly complex settings file. You can also use an alternate settings file if you'd like. So you notice here I've got a local settings.gradle. And I can do, with the -C option, it says use that as my settings file. And then I will say projects. And lo and behold, it looks pretty much the same. So if we go look at that file, here's a much simpler settings file, which just has a listing of these are all the modules that I want. And if you don't need variability in, or very seldom need to change the set of modules, this might be a very clear way for you to specify what modules you are to include. Okay. So let me. Oh yeah. So another thing that to point out just briefly here, this is the Gradle.properties file that is at the root level, where we specify a lot of different kinds of properties. And mainly it's versions of various things that we use. So if we go back to command line here, one of the other helpful tasks is something that will list all of the properties. And this is all context specific. So you can specify within any part of the build tree, you can specify different properties at that level, and then there's the global Gradle properties file that you specify in your user directory. And we explain how to set that up in the documentation that we have in labkey.org. So I invite you to read through that documentation to see how to set that up. And then, if you have any questions, be sure to ask. But this is a nice way to see, what kinds of properties am I using, what version of the various different plugins am I, or external libraries am I using. Okay, so those are helpful tasks. And now switch back to talking about a few developer scenarios. And so I'll go through a couple of different ways where you might do an initial build, either from a LabKey distribution or from a source enlistment. And then what do you need to do to add a file-based module to a LabKey server? What do you need to do to add a Java module? I'll say a few words about working within Intellij and Gradle, and then some important words about cleaning. So first, I want to give a very important note about versioning. So we released in 17.1, we have Gradle files checked into our 17.1 branch, but that uses a 0.9 version of the Gradle plugin. And so what you're seeing here, I am using the latest SVN trunk, and I'm using the latest 1.0 snapshot version of Gradle plugin. And we have been fixing bugs and improving performance and doing lots of things within this release cycle. So some of what you see here may not work with a 17.1 version of LabKey. So if that's where you're working, just know that your mileage may vary. Okay, so let's say that you get a LabKey distribution in your support portal, and you want to do an initial build using that distribution. So first you need to get your SVN enlistment, which you probably already have. And if you already have it and you've been building with Ant, it's important that you do an Ant clean before you transition to using Gradle. So I mentioned at the beginning that Ant produced non-versioned artifacts and Gradle produces versioned artifacts. So they look different, and the one tool can't necessarily clean up after the other one. So if you're switching between the two, you want to be sure to clean with the tool that you're switching from before you move to the other tool. If you don't do that, then you can get duplicates, and then the server is very unhappy. So you clean up your current distribution or enlistment, then download a distribution, and I say here copy it to the dist directory, and I'll show you that in a minute. Although that's not strictly necessary, because You can use different command line flags to point to a different directory. And then just like with Ant, you will pick your database, and then you can use a deploy distribution command. So let's go look at what that looks like. So I'm here in my root directory, and you'll notice that I have this dist directory, and I have already downloaded a community edition of 17.1 distribution. So I'm going to do a Gradle W pick PG, and that sets up my properties to use my Postgres database. And you'll notice that I could have done the full path to that that task, and it's actually defined in the server project. And so I say server pick PG, and it will do the same thing. But Gradle is smart enough to know that I'm at the parent, and so I will, if you give me a name of a task, I will look in my child projects to find any that have that task name. So it just saves in typing. Okay, so I set my database, and now I'm going to do the deploy distribution. This takes a little time because it has to extract things from that tar file, but it takes less time than if you're building all of these modules yourself. Okay, so now I have a distribution deployed, and if I go to my Intellij, exit out of presentation mode, then I can start my server. I'll come up here in a moment. And one thing I should say about building from a distribution, particularly a distribution created in 17.1, is that was built with Ant, and now you're sort of combining Ant and Gradle together, and that can be a little dangerous for the reasons that I mentioned before. Ant has unversioned, Gradle has versioned, and so you just want to be cautious about doing that and make sure you know what you're including. But I provide this as I think a useful example because when we have converted to Gradle and we're producing distributions with Gradle, this can be a really quick way to get going with a distribution. So now my server has started, and if I look at the admin console, I can see that I've got a number of modules that were deployed, and it's, you know, these are the modules that are included in the community distribution, and I'm ready to work with that LabKey server. So that's one way that you can get started. Probably if you're doing development, that is less common for you than if you're building from source. So the next example is that you're doing this initial build from source. And again, you start with the same way. You get your SE enlistment, or you do an Ant clean. You pick your database, and then you do your deploy application. So in this case, where you had been doing Ant build, now you will do Gradle W deploy app. And Oh, one thing I forgot to mention for the previous case, so when deploying from a distribution, this will deploy all of the modules that are contained in that distribution file, regardless of what you have set in your settings file. So it just unpacks the distribution, puts it into the deploy directory, and then you can start up the server. Building from source will actually use your settings file. And so this is really the more common case. So now, let me switch back to the command line here. I'm going to first clean out the previous distribution. And you'll notice that the clean deploy also stops the Tomcat server. So sometimes IntelliJ doesn't actually recognize that it's been stopped, but it does stop Tomcat, and then it cleans things out, much like the rebuild command from Ant. So now if I do deploy app, and this is going to give you a slightly skewed view of how quickly this goes, because I've obviously built in this directory before, just to save time. So, but we can look back through the output here, and you'll see that it's walking through all of the various projects, so the server API and the server internal and the server modules, walking through all the tasks that are necessary for building a module file for each of these modules, checking to see did anything change, and if it did, then it'll rebuild. But nothing has changed since the last time I did this morning. So now I have a newly deployed server. I can start it up again, and then can switch back to there it goes. And if I switch back to my admin console, we'll see it's a much smaller set. It's just those handful of projects that I included in my settings file. So that gets you with some distribution. And now let's see what you need to do to actually add a new module to a distribution. So in general, there are 3 steps. There can be more, but or less actually. But there are 3 steps to adding your own module to a LabKey server build. One is to apply the plugins that are necessary in your build.gradle, or you can just put your own build logic there, but you should certainly try to use plugins where they are available. And then, if your module has any dependencies, you would declare those dependencies in the build.gradle file, and then you deploy your module. So those 3 steps apply for most any type of module, but I'll go through a couple of examples. One is for a file-based module. What does that look like in particular? So you apply the plugins in the build.gradle, and there are 2 plugins that you want to use. One is the Java plugin, which you might think is strange, given that it's a file-based module, it's not a Java-based module, and so why do I need to know anything about Java? But that Java plugin, which comes from Gradle, provides some infrastructure for building, say, the module file itself. So we apply that plugin to get that configuration settings and the like. And then you'll want to apply a plugin that comes from our Gradle plugin jar, which is the file module plugin. And that just knows about the recommended or the required directory structure for a file-based module, and it will package things up and put them into a module so it can be deployed. Step 2, declare dependencies in the build.gradle. That is probably not going to be needed for a file-based module, but you can do it. And that is done with a dependencies block within the build.gradle file. I don't have an example of a file-based module that uses that, but we'll see that in the Java module, and it's very much the same thing. And then you deploy the module from the module directory. And to do that, if you go into the module directory and you type Gradle W deploy module, it will package up the module, put it into the deploy directory. Tomcat will recognize it, it will restart, and your module will be there. So deploy module, this task, among all others, will probably be your new best friend, because it is the targeted deployment that allows you to do some rapid iteration on changing modules. So let's go look at an example. I have a very, very simple file-based project that is just has a few resources, an HTML page, and some JavaScript. And so the Gradle file for that looks just like this. It has applied to plugin Java and applied to plugin file module. So now if I go to my settings file and I come down here and I uncomment this line, means I want to include the barcodes module into my build now. And then I switch over to command line, and I've already deployed the application. So now if I go into the local modules barcodes directory, so here I am with the build.gradle file, and now I say Gradle W deploy module. Again, I have already built this module once today, so it recognized that everything was up to date, but it did have to put the module in place. So it deployed the module, and now Tomcat is restarting because I have new files in its directory. And then if I go to the admin console and I reload this page, we will see that we now have the barcodes module. So that's a file-based module, fairly simple, and then you can iterate quickly on adding more content to that module. So the next example is a Java-based module. Looks very much the same. The only difference is that you apply the Java plugin and the LabKey module plugin. And then the dependencies you probably will have, are more likely to have dependencies that you declare. So let's go look at that. Okay, so I have here is a fairly simple Java module, which I apply the plugin, the Java plugin, and the LabKey module plugin, and then I have a dependency on another LabKey module, which is the workflow module. So I declare this, and again, I invite you to read the documentation for Gradle about what this syntax actually means, but I will point out a couple of things. So within one of the things that the Java plugin brings in is a set of configurations, and one of those configurations is the compile configuration. So I'm saying with this statement that the compile configuration depends on the API configuration for the workflow module. And the line below it is another way to say that using the build utils that comes from the LabKey Gradle plugins, but for current purposes, the line above should be sufficient. So that's an example of how to declare a dependency on a project or another module. And then if we go look at the workflow build.gradle file, it's slightly more interesting in that it has dependencies on some external libraries, as well as dependencies on another LabKey module. So external is actually a dependency that we declare in our plugins, and it's used because when we package up the module file, we want to pick up the libraries that we require that are external to LabKey and put those in with the module. But we don't want everything, so we separated it from the compile and just created this other dependency. So I've declared dependencies on these 5 different, or 6, I guess, different external libraries. And then this syntax is referencing a property for the project where I've defined what are the various versions of these. Separating these out into properties files is just best practice. It's easier to maintain that way. And then you can do all sorts of, have lots of flexibility of how you can declare these dependencies, and including and excluding things. And here's an example of, this engine brings in Java XMail, we bring it in somewhere else, the versions are not compatible, so we need to get rid of it. Okay, so that is a view into, brief view into how you declare dependencies. So now if I go and I comment this, I uncomment these 2 lines, and then I go back to command line, and I come back up here. And now if I do projects, I have lab work and I have workflow. And so now since I brought in 2 different projects, I'm going to need to build both of them or deploy both of them. And I could do this with a deploy app, but I'll just show you this. So now I've deployed those 2 new modules, and they are being included in the distribution that is starting up as we speak. And so if I go back to my admin console, reload the admin page, and now I have workflow and I have lab work. So, just briefly want to talk about Intellij and Gradle. I am by no means an Intellij guru, but a couple of warnings at least. As I mentioned a couple of times, the project that you want to use is located at the root directory. So when you are starting up Intellij, you want to open it and point it to the root directory. When you do that, Intellij may pop up a message that says, hey, I see you've got a build.gradle file. Do you want me to do the link of that Gradle project? And the answer should be no. The default behavior for that, at least currently, is not what we need. So you can say no, and you can say, don't show me this again. And instead, what you will use when you start it up, pointing at that root level project, you should see a Gradle window, and then you will want to do a sync operation within that Gradle window. So this is kind of hard to see, I know, but you should see somewhere on your Intellij window this Gradle window. If you click on this, you'll get this window, and initially it'll be empty because you need to do the sync in order for Intellij to read through your settings file and generate all its IML files, and then you will see a window that looks like this. And if it happens that you are navigating through your code and you find all sorts of red squigglies, usually the issue is either you haven't done a Gradle sync since you last updated your settings.gradle, and so Intellij just doesn't know anything about the dependencies or the class path for the code that you're navigating through, or for some of the code within the LabKey distribution that depends on generated things that are generated from XSDs, for example. You need to have built those jar files in order for Intellij to know about them. So you may need to do a command line build in order for things to get resolved properly. That is true also with the Ant build. Okay. So finally, I want to talk a little bit about cleaning up, because as I mentioned, Gradle is, because it does dependency management and configuration, it does more work, and so it can be slower. But you can help it to be faster by not doing unnecessary cleaning. It is good at recognizing when things need to be built and when things don't need to be built. So if you have this pile of blocks and someone you know has done a nice job of putting them into some configuration that mostly works, and then you decide, well, you know, that top block really needs to be red instead of brown, or I need to swap the green and the red, you don't want to go down to the ground again and start all over. You just do the small maintenance that you need, and things will go faster. All right, so don't resist the urge to just start over from scratch, because you'll just be wasting time. So to understand what you should clean at any point in time, you might want to know a little bit about how the build progresses. So we start with the source directory. when you do a build, it puts things in the build directory. And then when you do a deploy module, it will also do if that's the only command, it will put things in the build directory, and then it puts them in the staging and deployment directories. So there's a build staging modules directory and then a build deploy modules directory. And you may remember that when I was showing you the example of building from a LabKey distribution and then switching to building from source, I did a clean staging and a clean deploy. And that was to remove the staging and deploy directories, but not the build directory, because that didn't change. So there are lots of different cleaning commands that you can use, and I encourage you to use the one that is the most targeted for the thing that you need to clean up. So there's clean, which just removes a module's build directory. There's clean deploy, clean staging, and then there's the big hammer, which is clean build. It removes the entire build directory, and it's like knocking over the tower and starting from just rubble again. So that one should be used infrequently if you can. Okay. So just a reminder of the transition timeline. In release 17.1, we introduced Gradle into our version control, and it used version 0.9 of the Gradle plugins, which, as I mentioned, has some known issues. It's mostly functional, but not everything that I've shown you here today will work. And also, not all of the tasks from Ant had been converted in the 0.9 version of that plugin jar. And documentation is there, but it's still in progress, which I guess is always true. Most importantly, in release 17.2 timeline, we plan to complete the conversion, which means that we will remove Ant from the distribution, we will remove the build XML files, and we will remove the Intellij project in the server directory and all of the IML files that have been checked in. And this, we will begin doing this removal soon, so possibly next month in May, but certainly we will have done it in June. So I encourage you to make the switch now, and let's figure out what questions you have and what problems there are. There are various resources that you can consult. LabKey docs, as I said, we're developing that documentation, and then of course there's the Gradle docs, and as always you can post questions to the LabKey forum. So I went a little long there, but I will gladly take any questions that you have at this point.
All right, thanks, Susan. We have one question that came through in the chat panel, and that is, on the old system, Tomcat didn't have to reload updates on a file module. Is that functionality gone?
That is not gone.
Awesome. All right, if anyone else has questions, go ahead and submit those in the chat panel. You can also, if you want to use the raise your hand function in the webinar interface, I can unmute you as well. All right, well, it doesn't look like we have any additional questions. As I mentioned, this recording, or this webinar was recorded, so we will distribute that after the session, and so it's available as a resource for you. If you do have other questions, feel free to reach out to us or the documentation team on our support site. All right. Thank you very much, Susan. Everyone, have a great day. Thanks for joining us.